KCET 2025 aspirants, so very few days are left for KCET examination, and these last days are very critical, and it's time that in this period you should do a lot of question practice. So that is why today I have come up with top 30 questions from the chapter, one of the very high weightage topic, that is your coordination compounds. Okay, so it includes previous year questions as well as most expected questions, similar questions. If you do these 30 questions, then you'll have a rough idea about all the questions that will be asked, and I'm very sure that you will be able to solve those questions as well. Okay, so let's move forward with the first question, that is the number of precipitable halide ions are. Precipitable halide ions means those ions which are present outside the complex, which can be used for precipitation reaction. So you have one chlorine atom here, right? So that is why answer will be option number D. Okay, just a minute. Okay. Yeah, next moving to question number 2, which will give Fe3 plus ion in the solution. So here Fe is inside the complex, this one will not give. Here Fe is inside the complex, this one will not give. Here Fe ion will be produced, but if you see Fe2SO4 whole 3 is formed like this, Fe3 plus and SO4 2 minus, right? So yes, Fe3 plus ions can be produced here. Option number B is the answer. Here ma'am, what happened? Here if you see NH4 plus SO4 2, and here if I see it is Fe2 plus ion is produced here, okay, in this one, not Fe3 plus. So this is not the answer. Option number B is the correct answer. Next, the neutral ligand is, so chloro is a negative ligand, hydroxo is a negative ligand, oxalato is C2O4 2 minus, if you remember, C2O4 2 minus, this is OH minus, and this is Cl minus, and amine is your NH3 group, which is a neutral ligand. So option number C is the correct answer. Next, which statement about the coordination number of a cation is true? So you can see, I'll tell you the answer. The coordination number is the equal to the number of ligands bonded to the metal atom. Okay, directly the definition of coordination number, that is option number B. Next, CONH3 whole 5 Br SO4 and CONH3 whole 5 SO4 Br are the example of. So when you ionize this one, you will get the ion, this whole complex and SO4 ion. And here when you ionize, you will get this whole complex and Br minus ion. So when you ionize it, you get different ions, right? So that is why this is an example of ionization isomer. Next, which ligand produces a higher crystal field splitting? Stronger the ligand, there will be better splitting, right? And if you see, these all are strong field ligands, so I can say all of them will give you a very high, so it is not asking you highest crystal field, okay? So in which generally these ligands, if they are present, they will split the d orbital to the maximum extent, and the crystal field splitting will be very high. So I will have all of the above as the correct answer, okay? Next, K3Al-C2O4 whole 3 is called as the name of the compound. So first of all, it has to be potassium. So potassium, correct. Next, I have to name the ligand, right? So aluminium, no. There are 3 ligands, so that should be mentioned. So these 2 are wrong. Here trioxalato, yes, these 2 are still in the game. Now if you remember, if the metal belongs to the anionic complex, right, if the metal is a part of anionic complex, then the name of the metal will end with ATE, right? That is the rule. And here you can see it is given aluminate, here also aluminate. Yes, both are satisfying here also, but after the name we have to mention the oxidation number. Here you can see there is no oxidation number. I will eliminate this one. So option number D. Okay. Next, which is true in the case of FeCN6 3 minus complex? Okay, let us draw this one quickly. So I have given you 4 examples that is there in our NCERT book. What is it? CONH3 whole 6 2 plus or 3 plus, I think. Then you have COCl6 3 plus, right? Then you have NiCl4 2 minus, and then you have NiCN4 2 minus, right? So these are the 4 complex or the compounds which is given in our NCERT book. Anything other than that, if it is asked, how can we solve? Let me tell you. Fe, what is the electronic configuration of Fe? It is 3d6 4s2. Now here if I check the oxidation number of Fe, it is X minus 6 is equal to minus 3. What is the value of X? It is plus 3, right? So I will get Fe as plus 3, and that is your 3d5. Fe is plus 3, so that will give you your 3d5 configuration. Now if I draw this 3d, okay, 1, 2, 3, 4 and 5, 4s, 4p. Okay, now you see here, because Cn is a very strong field ligand, what will happen? Pairing of electron will take place. So once this pairing will take place, I can have these 2 electrons paired up here and here. 1 electron is remaining, and you see there are 6 ligands, right? If there are 6 ligands, 6 empty orbitals will be required. So I have D2sp3 hybridization. D2sp3 hybridization. So now let me see what are the things. The hybridization is D2sp3. Yes, that is correct. It is paramagnetic. Yes, because I have 1 unpaired electron here. So paramagnetic. 1 unpaired electron, that is also correct. So all of the statements are correct. Option number D is the correct answer here. Next, again the nomenclature. So I have here amine group, so hexaamine, hexaamine. Here there is no hexaamine, I can eliminate these 2. Here also hexaamine is there. Okay, after that you have to mention the name of the metal. Here tricobalt is there, that is again wrong. So option number A is the correct answer. Next, which one is a bidentate ligand? So C2O4 2- is also bidentate, and NH2CH2CH2NH2 is also bidentate. So both are bidentate ligands. Option number A and B, that is option number C is your correct answer. The complexes with CN ligands are usually, so CN ligands if you see, okay, these are strong field ligands. If strong field ligands are there, then what will happen? Pairing of electron will take place. Now just see this one. Here there was CN ligand, right? So now because of this pairing, this spin is 0 when plus minus half. The spin value is plus half and minus half. So plus minus 0, plus minus 0. So now the spin is only plus half, right? If it would have been any weak field ligand, for example, then there the condition would be like this. There would not have been any pairing. So 1, 2, 3, 4, 5 and I have 3d5. So in that case there will be no pairing. So how much I will have the spin value? 5 plus 1 by 2, it is 5 by 2. So and here because of pairing the spin is only 1 by 2. So what happens is whenever there is strong field ligand, there is pairing of electrons, the spin will decrease and we call it as low spin complex. So here complexes with CN will have you low spin complexes, that is option number B. And it is not only for CN minus ligand, any strong field ligand will give you low spin complexes. Next, which is an inner orbital complex? So inner orbital complex means you should have coordination number 6, so D2sp3 hybridization, and inner orbital complex is also formed when we have strong field ligands. So yes, here also we all have strong field ligands here, so definitely there will be pairing of electrons and we will get inner orbital complex. Now if I want to FeCN6, I have already shown you, that is D2sp3 we just derived. Let me check for this one. Here Mn is in plus 3 oxidation state, right? Mn in plus 3 oxidation state is 3d4, right? So if I have this one, yes, 1, 2, 3, 4, okay? So I just need 1 electron. So I will have, there will be pairing because it is a strong field ligand. So this 1 electron will pair up here, okay, and you will get D2sp3 hybridization. So this is also an inner orbital complex. Now COC2O4 X minus, so this is X minus 6 is equal to minus 3. So cobalt here is plus 3 oxidation state, right? So cobalt plus 3 means again 3d6. So cobalt electronic configuration is 3d7 4s2. Now cobalt 3 plus is equal to 3d6. Okay, so now I will get what here? You can see that 1, 2, 3, 4, 5 and 6. Now because it is a strong field ligand, again there will be pairing. So here there will be pairing. These 2 electrons will be, or these 2 orbitals will be vacant, and it will give you D2sp3 hybridization. So all of them are correct. Okay, all of them are correct. Next, question number 13, the tetrahedral crystal splitting is only dash of the octahedral splitting. So we know that delta T is equal to 4 by 9 of delta O, and that is option number C. Okay. Next, which is the correct order in spectrochemical series of ligands? So if you have remembered, you should be knowing chlorine minus, F minus, C2O4, NO2, and then Cn. So definitely the thing that you can easily eliminate is this one, because F minus is a weak field ligand, oxalato is we know that Cn is a very strong ligand. Then confusion may be here again if you know that halogens are weaker. So option number A is the correct answer. Next, which is an outer orbital complex? So outer orbital complex will give you sp3d2 hybridization, where we use the outer d orbital. And if you remember, as I told you, D2sp3 is for weak field ligand, outer orbital or sp3d2 is for outer orbital is for weak field ligand, okay, and inner orbital is generally for strong field ligand. So just write down this one. If I want outer orbital, then I should have a weak field ligand, and for inner orbital I should have a strong field ligand. Okay, so here you can see all are weak field ligand, so all of them will give you outer orbital complex. Next, the shape of the molecule complex AgNH3 whole 2. There are only 2 ligands, so if there is 2 ligands, the shape is always linear. So option number D. IUPAC name of this one. So first I have potassium, so all of them have potassium. Next I have tetrahydroxy, tetra. Here I can eliminate hydroxido. This is plus, this is minus, this is anion. So I have zincate, this I can eliminate. Now if I check the oxidation state, potassium is +2, zinc is X, this is -4 is equal to 0. So this one will give me +2, right? So +4 I can eliminate, +2. Option A is the correct answer. Next, which of the following has the highest molar conductivity in the solution? So molar conductivity is affected by the number of ions produced, right? How many number of ions are produced? Always complex will be 1 ion and rest auxiliary or counter ions will be counted. So here I have 1 this complex and 4 chlorine ions. So total number of ions produced here is 5. Here I have 1 ion and 3 ion, so 4 here. Here I have 1 complete this one and 2, so 2 plus 1, 3 here. Here I have 1 plus 1, that is 2. So the answer for this question will be option number A. Next, which of the following will not show geometrical isomerism? Geometrical isomerism, you need what all things? So I can have either, see, if I have coordination number 6, okay, what all are possibilities? I should have MA4B2 type ligands, that is there, then I can have geometrical isomerism, or I can have MLL2A2, this is your bidentate ligand, then it will show me, or if I have MA3B3, that will give me geometrical isomerism. And if I have coordination number 4, then I should have MA2B2, okay, and I can have MABCD. Okay, these forms will only give me geometrical isomerism. Now if you see here MA4B2, this is first type, so this will show geometrical isomerism. Here if you see this is a bidentate ligand, LL2A2, so this one will also show geometrical isomerism. Here this is of what type? If I see, it is MA1 ligand of 5 times and then B. You can see that I have not given this one here, so this one will not show geometrical isomerism. Here coordination number is 4, so it is MA2B2, so this one will also show. So correct answer will be option number C here. Next, which of the following complex species do not involve in D2sp3 hybridization? So D2sp3 means what? Inner orbital. Inner orbital means what? A strong field ligand, right? You have to find which is not having D2sp3. Okay, so here you can see strong field ligand, strong field ligand, strong field ligand. So here always there will be inner orbital complex, but and D2sp3, but this is a weak field ligand, so it will not show. Rather this one will show sp3d2, or I can say outer orbital complex. Okay, so please remember, if I have weak field ligand, for coordination number 6, generally the hybridization is sp3d2. Please remember the word I am using here, generally. Okay, there may be some exceptions or some other conditions, but generally this is happening, and for strong field ligand you need d2sp3. Okay. Next, the compound are given at the example of, so here NO2 is used, here ONO is used, ambidentate ligand, linkage isomers, option number B. Which of the following compounds would exhibit coordination isomerism? Coordination isomerism, for that you need to have two complexes, right? So this is one complex, this is one complex, the ligands can be exchanged here, so option number B here. A complex of platinum, ammonia and chlorine produces 4 ions per molecule in the solution. The structure consistent with the observation is. So you have 4 ions. So if I see this particular structure, this is whole complex, it will give me only 1 ion. If I see here, this one will is as a whole complex, it will remain, this one will also give me 1 ion. Here 3 and 1, so this will give me 4 ion. Here 2 and 1, this will give me 3 ion. So correct answer will be option number C here. Next, which of the following represents a chelating ligand? So chelating ligand is generally you should select a polydentate ligand. Okay, it can be bidentate or it can be tridentate, hexadentate, but it should be a polydentate ligand. So Cl minus monodentate, OH minus monodentate, H2O is also monodentate, DMG is a bidentate ligand. Okay, so it is a chelating ligand here. The IUPAC name of the given compound is, so first of all amine group is there, so tetraamine. So I can find here, there is something here, tetraamine is there, okay. Then there is one more, that is nitrato, right? This ligand is nitrato, but after this one only copper is given. So this also I can eliminate. So dinitrato, tetraamine, copper 2. Now here a question may arise that ma'am, it is not given alphabetical order. Yes, I do agree, but whenever such options are given, you have to find the most preferable answer. Okay, if all the answers are wrong, then you have to find the answer which is most closer to the correct answer. So definitely these two are wrong, because here they are not treated as ligand at all, right? They are written outside here. So here I can say that this is a more appropriate answer. Okay. Next, nickel combines with a uni-negative monodentate ligand X minus to form a paramagnetic complex NiX4 2 minus. Okay, the number of unpaired electrons in the nickel and the geometry of this complex is what? Okay, so first of all it forms a uni-negative monodentate ligand X minus to form a paramagnetic complex. So if I see nickel, what is its electronic? This is a good question. What is its electronic configuration in this particular compound? Monodentate, so it is monodentate means this is -1, so X minus 4 is equal to -2. So nickel is +2 oxidation state, it is 3D8, right? Now 3D8 if I draw, I have 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. So in 3D8 what will happen? This will pair up, right? Because it is a, okay, no, the question is asking that it is a paramagnetic complex. So if I pair, it will become diamagnetic, right? So it has to be paramagnetic because it is given that it is a paramagnetic complex. So I have to use this S and this 4P, right? Where it is having here X, 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 X. So I will have sp3 hybridization, right? So the question here is the number of unpaired electrons. So here I have 2 unpaired electrons, okay, so I can eliminate these two options. And the geometry of this complex, so because it is sp3, it has to be tetrahedral, so option number A is the correct answer. Next, the ionization isomer of this one. Ionization isomer means when you ionize it, you should get different ions, right? So if I see here, what I can see, the other things should be same. So if I see the first option here, this one has been converted, but the ions will be same only. So this is linkage isomerism. I can say option number A. See here NO2 is there and this Cl has gone out, No, this is also not, because here the structure is, the number of ions are different, right? Here I will get 2 ions, here I will get 3 ions. So this is also not correct. Here can I say yes? Here if I say chlorine will come inside and NO2 will go outside, and here also if you see that the number of ions produced will be 1 and 2, here also 2. So correct answer will be option number B here. Next, which of the following is correct in the increasing order of their molar conductivity? So again you have to find the number of ions here. So I have this complex increasing order of molar conductivity, okay. Here I will get 1 plus 1, 2 ions. Here I will get 1 ion. So it is not increasing. So this compound should be given in the starting. So this one, here I will get 1 ion. Here I will get 2 ions. And here I will get 3 plus 1, 4 ions, right? 1, 2 and 4. So the correct answer for this question will be option number, okay, just a minute. Yes, will be option number B here, okay. Next, the square planar complex MABCD are different ligands here, okay, this is ligand gives. So this actually gives you, I have already explained you, 3 geometrical isomers, okay. In that you have 2 cis and 1 trans, okay. So please remember this one. So the correct answer will be 3 geometrical isomers, okay. Last question, which of the following statements about the complex CrNH3 3 plus is wrong? So it is a paramagnetic. So if you see, I have told you to remember this because it is given directly in your NCERT book. This is a strong field ligand. Pairing of electrons will take place. So it is a diamagnetic complex. So this complex is paramagnetic. That is wrong. Option number A. It is an outer orbital complex. Okay, this is also wrong because it is an inner orbital complex. The complex gives white precipitate with silver nitrate solution. Okay, one second. The complex involves 2 3D sp hybridization. Okay, it is D2sp3 actually written. D2sp3 hybridization and is octahedral in shape. So I think this one is wrong here, which is the statement correct you have to find. Okay, so this is wrong because it is diamagnetic. It is not an outer orbital, it is an inner orbital. So this is also wrong statement. And the complex, there is no chlorine, so you won't get any precipitate. This is also wrong. And the correct statement for this one will be option number D. Okay, I hope this is clear. Okay, so that's all students. In this video we have solved all the 30 questions and I hope these questions were easy, and from this chapter you will get easy questions only. So please do not worry, just revise all the concepts, and if you have any doubt in any question you can put it in the comment section. I will definitely address to it. Okay, do not worry. And students, please remember our target is 60 out of 60 in KCET Chemistry. So if you are in this journey, please put down in the comment section 60 out of 60. Okay, that's all, and all the very best. Please prepare hard. Just 20-25 days are left. Let's put our 100% efforts. Okay, bye bye.